Now you guys learned about how magnetic field comes from a dipole, correct? So let's see how a bar magnet behaves in an external magnetic field. Okay, so that's basically torque. So what you have is you have an external magnetic field. You are placing a bar magnet in an external magnetic field. Okay, so it's making some angle theta. Fine. Now what happens? Because of the magnetic field, there will be force which will be acting on the poles of the magnet, correct? See, you have, this is one force, this is one more force. All right. Since two equal and opposite forces are acting on the same object, the body rotates. That's basically torque, right? The moment of a force. So now what you have angle theta. All right. So let's complete the triangle. See, this is we are completing the triangle. Next, what we have, so if this is theta, this will be angle theta, right? Okay, now we need to figure out what is the opposite side, because what is the formula for torque? The formula for torque is force into the perpendicular distance, right? We can figure out what is the force. We need to figure out what is the opposite side in this case, because that's the perpendicular distance, right? So you have triangle NSP. Okay, so we need to find out what is sine theta, because sine theta is based on opposite side, correct? So if you take sine theta, you get SP by NS. So SP is equal to NS sine theta, right? Now NS is what? The length of the magnet, that's 2L. So you have SP is equal to 2L sine theta. Okay, now we need to find out force. So F is equal to the magnetic pole strength into the external magnetic field. So you have F is equal to M into B. So substitute all these things. So you have torque is equal to, you have MB into 2L sine theta. Right? What is M into 2L? Magnetic moment. So you have torque is equal to MB sine theta. Now MB sine theta, it's a vector product. So torque is equal to tau is equal to M cross B. Okay, so this is basically the formula for torque. Alright.